Hey y'all, I'm David, and this is Lab 2 bar magnets. So for our introduction, the purpose of this lab was to observe the on and off axis fields as well as their distances using a magnetometer, and then determine the distance dependence of the magnetic field of our bar magnet and create a computational model. And for our preview, I got the value of n to be negative 2.94, and I got the dipole moment to be 2.95. And then the observed uh, B net was 3.63 times 10 to the negative fifth, and our expected was 3.03 times 10 to the negative fifth. The fundamental principles for this lab were the Biot-Savart law, the magnetic field of a dipole, and the distance dependence formula. And here are the formulas for those. And then this is the linearization of the distance dependence formula so we can graph it. So for the experiment, our system was our magnetometer, and the surroundings were the bar magnet and Earth. And so we set up our x-axis, and then we tested the magnetometer on axis and then off axis as well, to get it to reach certain values, and then we'd see what the distance was. And here is the table of the measurements for that, and then the graph of our linearization. And this is where the n value comes from. And then here's the off-axis data. And the corrected values were calculated based on the Earth's magnetic field. And the mu that I solved for was 2.95, or dipole moment. So for the code, uh, we just initialized some things here, and then created our axes, two on axis and four perpendicular, and then uh, set up our dipole moment. And here we're just creating arrows to represent the different magnetic fields, which you can see here. The sources of potential error for this lab, there could have been external magnetic fields that weren't accounted for, because we only really accounted for Earth. And then there could have been changes in distance and angle of the magnetometer. They could throw data off. Uh, what if what if in the experiment you oriented your setup so as to compensate for magnetic north? What if we hadn't done that? How would the results have changed? So the magnetic field of Earth would interfere and would change measurements if it wasn't compensated for. And then if we redid the experiment, but instead of using a single magnet, we put two identical magnets stuck together end to end, how'd the measurements change? The magnitude of the magnetic field would double, but it would still have the same direction because they're end to end. And yeah, thank you.